So today we'll be discussing the, starting from Spark, what is Spark and how does that help and what are the different component of Spark. Um, you all might have some basic understanding of Spark. So some of this might be repetition for some of you, but bear with me for the benefit of everyone. So Spark has different modules. It has Spark Core, SQL, streaming, machine learning library, and graph. This is the representation. The code, the code which is common across multiple components goes in Spark Core. And if you want to use, there are different libraries for SQL, streaming, machine learning, graphics. And Spark can work on, and I have slide for this also later. It can work on Spark, and you can run Spark as a standalone, or you can run on Yarn, or you can run on Mesos, or now Kubernetes is also there, so you can run on Kubernetes as well. Yeah, this is what we discussed. Now, why Spark is needed? So, before Spark, there was mostly people were using MapReduce. They were using Pig also, but Pig internally was starting MapReduce only. And the problem with the MapReduce was its design was that it writes data to the disk. And the moment you start writing to the disk, like mapper gets over, then it writes to the disk, and then reducer picks up from there, reads from the disk. So when you're talking about big data and you involve disk IOs, then by design, your job will become slow. So what Spark does is it tries to do everything in the memory. And that's why it is way faster than the MapReduce. MapReduce does not leverage the memory cluster as effectively, so it's slow because its design is writing to the disk, and then next steps like reducer and everything picks from there. Another advantage is you have the interactive shell. So you have Spark shell. You can try your program and practice your program there, or debug something there, and it comes quite handy. And if you have written ever MapReduce program, you would have realized that writing the MapReduce itself is a huge is a huge thing. You have to write a mapper, you have to write a reducer, then you have to write a driver, where you set the mapper, reducer, input directory, output directory, formats and everything. And if you have more, if you want to use combiner and everything, you have to write another class combiner. So minimum 3 classes you will write. I mean, you can all put in one class itself, but the minimum 3 components you will write. And if you want more, then you have to write like combiner, etc. You write more components. So Spark is not that way. Spark is very easy to code. And as you will see in the subsequent sessions, you don't have to worry about writing mapper, reducer, and combiner, driver separately. It's all part of one. They did some analysis. So logistical regression is a machine learning algorithm. So they ran for the same logistical regression for the same data set. They ran that algorithm over Hadoop and Spark. So Hadoop took these many minutes, and Spark got finished in this minutes. So this is the drastic performance difference between Hadoop and Spark. What are the Spark core concepts? So one thing I will recommend you, if you have watched my previous video, which was on the same topic, there also I'm indicating that this you never forget. Keep that in your mind always. At least this rectangle. And I'll tell you why. But before that, let me explain you what this diagram represents. You have a driver program. So you have a driver program, and as far as your construct goes, as far as your coding goes, everything is in one class. But internally, what happens is the code starts from the driver program. You always deal with Spark, but internally, there's a Spark context behind that, and that Spark context deals with the cluster manager to get the resources to get where the job should run, and that your code runs on worker node. So this is what you should keep in mind. Again, I'm iterating. The worker node can have one or more executor. Here in the diagram, we are showing only one executor, but it can very well have one or more than one also. One executor is one instance of JVM, and one executor can have one or more than one task. So this you always keep in mind. Your code runs inside the tasks on the executor, which are residing in the worker node. What is Spark session? It is entry point for Spark SQL. It provides a way. So here we are talking about Spark context, but in your in your Scala program, or in Python, or even Java, or even R also, you always deal with Spark session. And Sparks, all your code will be on, most of the code will be using Spark session, but once in a while you might need to use Spark context also, and we'll cover whenever we need to use Spark context later. So Spark session is entry point for Spark SQL. It provides a way to interact with various Spark functionality with a lesser number of constructs. So now, what do you mean by lesser number of constructs? Before Spark 2.0, if you had to deal with Hive, you had to create a Hive context. If you had to deal with SQL, you had to create SQL context. So likewise, there are a few contexts, you have to create a corresponding context. But in in Spark 2, they created Spark session, which unifies all the context. So with one Spark session, you can run Hive queries or SQL queries and everything. If you just have to, while creating the Spark session, you just have to say enable Hive, dot enable Hive support, like you're creating the Spark session here. So, and you say dot app name and say dot enable Hive support, then it will be available. It can interact with Hive also. And for by default, it will you can run the Spark SQL also using the same Spark session. So point is, you don't have to keep creating this different context. With one Spark session, you can do all of this. You can use the Spark session to create RDD, data frame, and datasets. We'll cover what RDD, data frame, and datasets are in a while. If you're using Spark Shell, in your Spark Shell, Spark will automatically give you, Spark session in a variable called Spark. So in your Spark Shell, you can directly say Spark dot read dot whatever CSV or whatever. If you are in a program and you want to create a Spark session, this is a construct you use to create a Spark session. You have to use Spark session dot builder dot master app name and get or create. The master, it tells you where you are running your Spark application. Is it on local, or is it on Yarn or Mesos? And now even Kubernetes also come. For Kubernetes, we'll discuss separately later. And this app name is a name which you give in the, which appears on the, on the UI. We should go to Spark UI, and we'll discuss Spark UI also in some session. So this application name will appear as, with this name on the UI. And get or create. If already exists, it will give it to you. If it does not exist, it will create one Spark session and then return to you. This is one pictorial representation. So you had the Spark context. You have the, for the core API, you have streaming context or streaming API, SQL context. Even in the streaming API, I think I should mention that we discussed this diagram, right? Spark SQL and Spark streaming. Now, in Spark streaming, what is happening is they came up with the structured streaming some years back. And the constructs of structured streamings are very similar to Spark SQL. This has data frame, this also data frame. And this has, Spark session exists in the Spark SQL. Now it exists in the structured streaming also. So once you learn the concept in Spark SQL, at least the construct wise, it remains same in Spark streaming. You just have to only understand how Spark streaming works. That's all. Now what this local and Yarn, I think you already know. Local means you are running on the, okay. You are running on the local machine, and Yarn, you are running on the Yarn machine. Spark session, you could have multiple Spark session in your program, in your application. What does that mean? If you already created a Spark session using get or create, use that Spark and say new session over this. So I just copied this from Spark documentation. I will read it out, then I will explain you what what these lines mean. It starts a new session with isolated SQL configurations. Temporary tables, register functions are isolated, but sharing the underlying Spark context and cache data. So when you create a new session, by the way, why do someone ask this question, and why do we need to create new session in first place? The reason you want to create new session in first place is, let's say in one session you want to deal with just Hive. In another session you want to deal with something else. And you don't want to deal with Hive in the session. So if that's your business, that depends on your business logic, honestly. But if that's your business logic, then you will create, two different Spark sessions. We'll discuss the temporary tables also later, not today in today's session, but in coming session. We'll discuss UDFs also. And of course, there's a caching, you can store your RDD and everything you can cache it or persist it. That also we'll discuss later. Get or create. This method first checks whether there's a valid thread locus Spark session. If yes, it returns that one. If it then checks whether there's a valid global default session. If it does not exist, then it check global default session. If yes, returns that one. If no valid global default Spark session exists, the method creates a new Spark session and assigns the newly created Spark session as a global default. Basically, what it is saying is, in layman term, if you have to understand, if the Spark session already exists, it gives you. If it does not exist, it creates and gives you. So that's what get and create does. This is a pictorial representation which I try to do. So Spark earlier used to have Spark context, SQL context, Hive context, Spark streaming context, Spark conf, all of this separately. Now you have one Spark session which has all of this together. It's the same diagram which I showed you earlier. So like this example, when instead of earlier you had to create a Hive context, now you don't have to create that Hive context. You can say .enable Hive support while creating the Spark session itself. And with the same Spark session, you can deal with Hive as well. You can pass various configurations in this. Some of this we'll discuss in coming sessions. What is driver program? You will be hearing this driver program a lot. Driver program is the class, in a programming terminology, it's a class which has main method. Whether it's a Java-based Scala program or Scala-based, or I'm assuming even Python-based, where from your program starts. So it should have main method. With the class which has main method, your driver class. It launches parallel operations in the cluster. So in your driver class itself, you will be creating RDDs and invoking various operations of RDD. So that's the only class you will have for writing the Spark program. But whatever operations you will be doing, in the code inside the driver program, that operations will be getting launched, in a distributed way on the cluster. It accesses the computing cluster. It's a driver. It creates RDD, dataframe, etc., dataframe datasets, which run in the cluster. Now the driver program itself runs in the master node in one of the cluster node. So let's take example of you are running on Yarn. So in the Yarn, you have a cluster which consists of master and worker nodes. So you can, based upon the configuration, which we'll discuss later in coming slide, you can configure for your driver program to run on the master node of Yarn, or you can configure it to run on one of the worker nodes. And what is that configuration? We'll discuss. The question is, there's a question, what will enable Hive support do internally? So if your data is in Hive and you want to read from Hive, or you want, so if this is one of the examples. So if you want to do that, then you enable Hive support. We might discuss something, about Hive architecture and everything. But if you want Spark program to deal with Hive, then you enable the Hive support. The driver program converts program into physical execution called tasks, and we'll spend good amount of time on this later. But idea is that we discuss this diagram, right? Which I told you to print in your mind. Always. I will again go here. This is a diagram which you should never forget when you're dealing with Spark. So there's a worker node, executor. Executor has task. One worker node can have more than one executor. So now the real split of task creation inside the executor happens via driver program. See, it's natural because all your code is inside the driver program anyway. So task creation and everything will get driven from the driver program. This is one example of driver program. It is written in Scala. Krishna asked what are stages. Krishna will discuss stages in lot more details later. Just bear with me. So this is one example of driver program written in Scala. Python program will be very similar to this. Whatever you see in Scala, using PySpark also you can write with some changes. So this is the way I created the Spark session. So you can say Spark session.builder. I'm running this on local. This is the app name. Now this is just an example. This will not be, you will not be creating such driver programs in production, because you might be reading from database or HDFS or Hive or S3 or Azure Blob Storage. So this your data I'm just hard coded some, rows and creating this data. But in production scenario, this will be getting read from one of these storages, which I just told. So just for, just for explaining, you have this row is a SQL, Spark SQL construct. In this row, you have 3 columns. And so I have created 2 rows. So this data will have 2 rows, each having 3 columns. And the schema, I'm giving the schema to, I'm creating a schema. So this is how I create the schema. So I create a struct type and I'm saying add. So internally, when I say add, it's creating struct field for me. I could very well create struct field, and I have example of those also later. But this is, I'm saying that this struct type has 2 columns, 3 columns. First column is called first name. It is of string type. Second column is called last name. That is also string type. Third column is salary. That's integer type, right? So first, second, and the salary. And then I create a data frame from this. So the way I create data frame from this, I say, because I have this data, I parallelize the data and I pass a schema. So that's how I create the data frame. Then I do something. Generally, when you create data frame like this, I will discuss it's lazily evaluated. Unless you do some action, nothing happens. Here, I'm not doing any actions. In reality, nothing will happen. But I can say df.save or df. I apply some operations, right? And we'll discuss a lot of these operations in coming sessions. Some transformation I apply, and then I take some action. Action is collect, save, take, count, some of these. Okay. Now there are some questions. What does indexing local -1 local -1 means? It basically means that I'm taking 1 core from my local. If I give star, it will take as many core as possible. Everything is case sensitive. I don't know, Karthik, and what even be case sensitive, but the syntax is case sensitive. Parallelize is a construct. If you have some list or something, right, then you can parallelize using this method. Spark context to parallelize. So mostly you, as I said, you will not be using this parallelize. You will be reading from the S3 or something. So there is a construct Spark provides Spark dot read or something, and we'll discuss that later. Yeah, you don't have to, Arun, you don't have to decide. There is no fixed way. It depends. Question is, how do we decide how many cores we need in local? Depends upon your load. Depends upon your hardware. Various factors go into deciding how many. People, can you please go on mute? Okay, so this is how you decide. The driver program, this we already discussed. App name is the name of the app. It appears on cluster UI. Master cluster URL, yarn for, if you give the yarn, it runs in yarn. If you give local, it runs in local. If there's a K8 something, you give, it runs in Kubernetes. Executor, we are double clicking on executor now. What executor is? It processes in worker process. These are processes in worker nodes in charge of running individual tasks of Spark job. It runs for entire life cycle of application. It provides in-memory storage for RDD. So when you're processing your data frame or data set or RDD, you need to, you need to get memory. So that memory is this memory, in the executor JVM. Whatever is memory, that's where the RDD or data set or data frame gets loaded. After the task is over, these send result back to the driver. One executor you have to remember is one JVM instance. Now these different tasks inside the JVM instance are multiple threads running inside the same JVM. It can run many tasks, as we discussed, sequentially or concurrently. If it has resources in terms of memory and everything, memory CPU to run task parallelly, it will run parallelly. If the tasks are such that JVM doesn't have those many resources in terms of memory, etc., then this task will run sequentially. So this is about executor. Yeah, I think Rajesh, very valid point. Please ask, don't direct a message to me for questions, put it in the comment forum. Others can also answer. Worker node, will cover the data frame whole later. And how does the driver node divide a DAG into tasks? I have a simulation for that. I will cover that as well later. If you don't get answered in by next session, then you please ask these questions. But it will get clarified once we cover all of this. Worker, it's a node which runs executor or executors. It can run one executor or more than one executors also. Task, unit of work on a partition of a distributed data set sent to one executor. Now, I will explain with an example what is task. In terms of Spark, let's say you have a file of 1 GB size on HDFS, and your HDFS block size is 256 MB. So there will be 4 blocks of that size in HDFS. 256 multiplied by 4 is 1 GB. So that 1 GB file is split into 4 blocks, and you write a Spark program to process that file. So in reality, it will create 4 tasks for you. In one executor across 2 executors, that depends upon how much executor memory and other things you will specify. But in reality, across executors, there will be 4 tasks. One task run, processing one block of the data. On HDFS, this is how it works. And these task and partitions are, one task is one partition. So one task in Spark means one partition in Spark. Spark application master, this is very specific to YAR. The Spark application master is responsible for negotiating resource request made by driver with YARN and finding a suitable set of hosts in which to run the Spark application. There is one application master per application. I think I explained you last time also, but I'll reiterate here. This is very, very specific when you are running your Spark job on YAR. So when your Spark job runs on YAR, what first thing which happens is an application master gets started on one of the node. Now this application master looks at the file and and varies in a couple of other factors and realizes it needs these many number of nodes. It needs this much capacity. I will not say number of nodes. It needs this much capacity in terms of RAM and CPU, etc. Then this application master will go to the resource manager in YAR, and then it negotiate those resource requests with the YARN resource manager, and resource manager will give the resources which this application master is asking, and then application master will spin up the executors and tasks on those nodes. So there will be one application master per Spark application, and you can go to this link. It's described in much details here. There are different Spark execution modes. You can run Spark in, I think we discussed that, right? When you give the local or YARN or something. So you run this in local mode. It runs on local machine. It's not a distributed, and mostly used for unit testing or some debugging or something like this. A standalone, I have not seen anyone using standalone, honestly. Maybe on some test machines or something where you don't need power of YARN or Kubernetes or something. The third execution mode is cluster. You can use YARN or Mesos, etc. If you use YARN, in YARN we discussed that there's a YARN cluster. You can run the driver on YARN. You can pass the configuration. I think I have next slide which tells you when you submit a Spark job. Let's talk about this. So when you submit a Spark job, you have, how it works is this. You have the, you want to process some file on HDFS. So write a Scala code or Java code or Python code to process this. So we'll be discussing Scala, but similar concepts apply for Java and Python, etc. also. So you wrote the code, and you created all your logic is inside the code. Now created a jar file using using Maven or using SBT. You created a jar file. Now you have to submit this jar file. Let's say you are submitting this, you have this YARN cluster where you can submit. So you say Spark submit and say -- class. This is your main class. This com.df.spark, this is the main class, the driver class, which has the main method. And then you give the jar file. This jar file should have this main class. And then you tell whether it's running, the configuration is YARN client or YARN cluster. And I have a detailed explanation of this YARN client and YARN cluster, but let's go this YARN. There's a difference between YARN client and YARN cluster and standalone also. So driver runs in application master here, which is mostly master node. If you give YARN client, it runs in one of the worker nodes. If you give a Spark standalone, then it will use one of the standalone is also Spark itself become the cluster manager. So question is, what's the difference between standalone and local execution mode? Local execution mode will always have non-distributed, one local machine, not executing the Spark code there. There's no distributed processing happening there. In Spark standalone, Spark gives you a default cluster manager. So there's a distributed processing happening on the Spark standalone also, but it's not as matured and as robust as Yarn or Kubernetes are. But you could use Spark standalone and have the distributed processing run. So on that, your driver also runs in one of the worker nodes. In the Yarn cluster and Yarn client, application master will go to the resource manager and ask the resources. And the Spark standalone, of course, because Spark internal cluster manager, so internally a client will figure out how many resources it needs and will use those many resources. Who starts executed process? So once application master asks the resource manager to, application master goes to the resource manager and asks for certain resources in terms of CPU and memory. So the resource manager will give those resources. Resource manager will tell application matter on this 1, 2, 3 hosts you can go and start your application. So application master go to those host 1, host 2, host 3, and that node manager is running on the host 1, host 2, host 3. So application master will tell on to node manager of host 1 to start that application there. Then it, parallel it is talking to host 2 also and host 3 also, and their own respective node manager it is requesting to start the processing. Whatever has, it will ask the resources whatever has been given to application master by resource manager. Question is, does it mean that in local mode there's only one node? Yes, and it's make it non-different. That's correct. Persistence services, I think I will skip all of that, most of that. There are some services in Yarn mostly you deal with the resource manager and node managers. Resource manager is the one which gives resources to the application master, and application master take those resources and spin those, tell node manager to run those resources there. When I say resources, it just means CPU and RAM mostly. In Spark standalone, this is Spark. There are Spark master services and Spark worker nodes. There is no in Yarn cluster. You cannot use Spark shell. The Yarn client you can use Spark shell. In Spark standalone, Spark shell is you can use. How do you specify local? Using local star. If you give star, it will use as many as possible, or you can give in brackets how many cores you want to use. If you want to use Spark standalone, you have to pass dot master, right? Remember when I created the Spark session, I said Spark builder, and then I passed some configurations, and one of the configuration was dot master, and I passed Yarn there. If you want to use Spark standalone, you pass Spark and your wherever the host name where your Spark standalone is running and the port name. Generally it's Spark, your local wherever your Spark cluster is deployed, that machine name, and the port is mostly 7077. If you're running on cluster, then mostly it is Yarn, and Yarn you either pass Yarn client or Yarn cluster. And I already explained Yarn client and Yarn cluster difference. I will have one slide in a subsequent also to explain the difference in little more detail. Or you can pass Mesos as your master, or as a cluster manager, or you can pass Kubernetes as a cluster manager. In the Yarn, if you pass a client mode, which is this, then what happens? The driver runs on a dedicated server, which is master node inside a dedicated process. Driver has all the resources available at its disposal to execute work. It opens up a dedicated NATI HTTP server and distributes the jar files specified to all the worker nodes. So whatever jar files is specified, if you are given the client mode, then it will automatically take care of distributing the jar file to the worker nodes, because your logic is executing on the worker nodes, and logic also needs to access these jar files. Important thing is, it does not use the worker resources because it runs in the master node. If you have limited worker resources and many jobs running, then preferably you do not want your the driver program to take one of those resources. So you can run if you give client mode, it will run on the master node mostly. If you give the mode as cluster mode, then driver will run on one of the worker node. Like in Yarn, it will tell you which worker node you go and run. Like we know that story, application master, resource manager, and everything. But net result will be the driver will not be running on the master node. It will run on one of the worker nodes. It runs again here also dedicated standalone process inside the worker. It takes up at least one core and dedicated amount of memory from one of the workers. So So which means that the resources on the worker which are getting devoted to the driver program. It can be monitored from master node using the supervised flag, and you can reset in case it dies. I have not seen this getting used often because most of the time you have resources on the master. Most of the time you can run in the master node, but once if you don't have then resources on the master node, then you can use this mode. All applications has to be, now here is the catch here. All applications has to be publicly available to worker nodes. The cluster mode will not take responsibility of copying your jars to other worker nodes. In this mode, in the previous mode, client mode, the driver took up the responsibility of distributing the automatically in the background. It happens. You don't have to do anything. But here, the jar will not be distributed public to the worker nodes. You have to manually put them in the shared place or on some HDFS folder, which all worker nodes have access to. So that's the work you have to do. The default mode is nothing. If you don't give any mode, the code won't even compile. Difference between YARN client and cluster mode, this is what just I explained. The YARN client mode runs on the master node and jars automatically get distributed. On the cluster mode, the driver will run into the one of the worker nodes, not on the master node, but then jar responsibility of distributing jar, you have to take care. In the cluster mode, what is the use of master node? Since the driver itself is stored in one of the cluster. I mean, yeah, in that case, there is no use of master node because however number of Spark jobs you are submitting, each of the Spark job is starting its driver on the one of the worker nodes. Only thing is, the initial submission, the application master and everything is even that is also getting created on cluster mode. So in that case, there is not much use of the master node is not at all getting used there in the cluster node. I will skip these questions. We'll discuss this later. When you use PySpark, yes, then still you have to use jars. We'll discuss RDD, and I try to give a pictorial view of what RDD is. So RDD is resilient distributed data set. Important thing to notice, these are very important things. Sometimes in our design or when we start thinking about RDD, we tend to miss this. First of all, it is fault tolerant, and second is immutable. What do you mean by immutable? First, what is the fault tolerant? I will discuss both of these, fault tolerant and immutability, once I explain you how RDD gets created and what RDD is. Then I'll come back to this. Elements can be operated in parallel. So now think about this. You have to keep the discussion simple. Let's say this is your Hadoop cluster or Spark cluster, and and HDF is also there. You have data stored. You have the a 1 GB file which is headed, and 256 MB is the block. So you'll have 4 blocks of that file. Let's say one block is here, second block is here, third block is here, and fourth block is here. So now, but in reality, this is just one file. It is just that it's stored in these 4 blocks. So the name node will know that file. So you can create an RDD, one RDD, and give the file name. I mean, I will show you how to create RDD by providing the file name in HDFS. But over that file, you can create an RDD. So in the driver program, for you, this is just one RDD. But in reality, if you do any operation over this RDD, let's say you map operation or map partition operation, and we'll discuss each of these operation in detail later. But you can do some operation, some transformation over this RDD. All these transformations are parallelly getting executed. In the driver program, you say, do this transformation on RDD. But internally, RDD is applying same transformation here for the data which is here, and here for the data which is here. So, and same in these 2 nodes also. But for driver, it is just one collection, which is just one RDD. Internally, RDD is executing the transformation parallelly here. Now, what is fault tolerant? Fault tolerant is basically if something goes wrong. I don't know. One example could be if worker node goes down, then there's a replica of this data stored elsewhere, right? So you don't have to worry about this, and RDD will still have the data. Immutable is if you do any operation of this RDD. So once you have data loaded into RDD and do any manage operation, I am in the transformation. So when you do any transformation of the RDD, that RDD will never get changed. Every transformation will result in a new RDD. And over that new RDD, if you do any more transformation, it will return in new RDD. So that's what immutability means. Yarn is fault tolerant. Yes, we discussed about Yarn earlier. I would suggest you to watch that video. There's a standby name node. From the HDFS perspective, yes, there's a standby name node and there's a secondary name node. Resource manager of Yarn is also fault tolerant. We have not discussed Yarn in detail because, in my view, after 2-3 years, Yarn will get replaced by Kubernetes. But to answer your question in short, yes, Yarn is also fault tolerant. There are two types of operations you can do on RDD. One is transformation and one is action. Now, what is transformation? Transformation is it construct, there are various transformation functions. You can do map, you can do filter, you can do map partition, and there are a hell lot of those things. We'll cover most of this later. So it constructs a new RDD from the previous one. Like I said, this RDD called line, and you say line.filter. And this is an example, and that filter will give you a new RDD. It never changes an existing RDD, but these are the one of the example of transformation. And every transformation will construct a new RDD from the previous one. Action, it compute result based on RDD. So a result is either returned to the driver or saved to external storage like HDFS, Cassandra, rdbms, or whatever else you might have, S3 or a blob storage. You can save any of this. Now, so take this example. Let's say there are 1, 2, 3, 4, 5. There are 5 rectangles I'm trying to show here. One rectangle, first rectangle, represents one RDD which you read from database or some file or something. Then you do some transformation, it turns second RDD. More transformation, it turns third RDD. More transformation, it turns fourth RDD. And then more transformation, it turns fifth RDD. Over this fifth RDD, you are seeing action. Action is RDD.save, collect, take, or whatever, right? So the moment you trigger an action, these RDDs are lazily evaluated. So if you don't have any action, you have only transformations, then nothing will happen. The moment you have action, then only the first action, then the executions of RDD will trigger from beginning till end. So and the here what I have tried to show is that first RDD you transformation, it gives second RDD. You do some transformation, it gives third RDD, and so on. So every transformation creates a new RDD. And at the end, you have some action, and then action can, action could be you are saving the RDD into some file or some storage, or you are collecting the result of RDD as a list or something, and that result can get returned to driver. So either of these things are actions, and we'll see some examples of actions later also. Does during RDD creation process copies data from any disk file system or blob storage to Spark cluster machines? It depends. If you are doing HDFS, I think I tried to explain example here. If you are, where did that go here? If you are using HDFS, then in data will stay here, right? And you can just create an RDD over this, data doesn't need to move. But when you're using blob storage or S3, and yes, then there'll be some movement of, well, during RDD creation, nothing will happen because I said RDDs are lazily evaluated. During action, these things will happen. With lazy evaluation, does every transformation create a new RDD or it gets stored in lazy? Good question, Arun. So what happens is you can do, if let's say you do not have any action here, you can do as many transformation as you want. Nothing will happen. Actually, none of this RDD will get created. And your driver program will just start it and finish it without doing anything. You have, these 4 or 5 transformation over RDD. First transformation itself will get triggered when you have some action. The moment you have action, then only first transformation will get triggered. First RDD will be created, sorry. Then first transformation will be applied over RDD, then second transformation, then third transformation, and fourth transformation. And each of these transformation will result in new RDD, but that gets triggered from the first action itself. If there's no action, there's nothing will happen. This is what I try to explain again. RDDs are lazily computed. This is what I was trying to say. Computed first when action is executed. If you don't have any action, then no RDD will be created. These are computed each time action is run. So this is a very important statement, and I'll try to explain what this means. So let's say you have one action which is saving it to a file. And you have another action over the same RD, which is saving into a database. For whatever reason, I have these two actions. Now, both actions are working on this final RDD. And this final RDD got created by reading from a file and applying these transformations. When I say first action, it will read from somewhere, whatever it's reading from, apply all this transformation and save into a file, because that's my first action. The second action, which is saving to a database, when I do that, it again does the same thing. Again, it's from the file, apply these transformations, and then save to a database, because that's what my second action was. So question is, after an action is triggered, each transformation will be triggered, and then each transformation will result in a new RDD. That's correct. That's correct. If RDD is used in multiple actions, then you should better cache it. Like there's a RDD cache or RDD persist, because when the example which I explained here, right? If for the same final RDD, I have this, I'm reading some file, creating an RDD from that, then applying all this transformation, and have this final RDD. When I'm doing two actions on this final RDD, one is saving to a file and second saving to a database, then both of these actions will trigger all of this reading from file and then each transformation. I don't need to do that. I could very well have this final RDD as cached. I can say I can use rdd.cache, and over that cache, no matter whatever number of actions are specifying, those, whole of this graph will not be executed. Only the final RDD will be saved. And we will have a detailed explanation of cache and persist later. This is just giving you a high level overview how this cache might help. I think I will use 5 more minutes, then I will open it for questions. So this is one example of RDD. So generally you will not be creating RDD from this array in the memory. You will be creating RDD by reading some file from HDFS or S3 Azure Blob Storage, and I'll explain you how to do that later. But just for our testing purposes, I want to test test some functions of RDD. Then I can create an RDD from this array, and then and you can read RDD. You can read RDD. One of the APIs to read from text file is this Spark context.txt file. So that also gives you an RDD. Or if you have some data in the memory, from there you want to create RDD, then this is how you do. These are two examples of creating RDD. Now, one thing I will, I think we are almost. I will explain data frame and dataset, and we'll go into details later. So, like RDD, data frame is immutable distributed collection of data. But unlike RDD, data is organized into named columns like rdbms. So your column 1, column 2, column 3, each row has these columns, right? You can use Hive, CSV, CSV, JSON, Parquet, what you call ORC, sequential file, rdbms, XML, Cassandra, RDD. All of this can be converted to data frame. What I want to do next time is, let me cover dataset also. Distributed collection of data. It was got added into Spark 1.6. It provides the benefit of RDD, which is strong typing and ability to use Lambda function. And I'll talk about Lambda function in a later. And it provides the advantage of optimization engine. Over RDD, you don't have, Spark cannot run much optimization. But over a data frame and dataset, Spark can run much optimization. Data frame is best suited for the optimization. Spark optimizes data frame in best possible way. Datasets also it optimizes it, but RDD cannot optimize. In PySpark, you don't have dataset. Dataset is available only in Scala and Java. It can be constructed from JVM. Dataset can be constructed from JVM objects. Let's say you have a class person, and it has two variables, name and age. So you can construct, a data set using this. I have a detailed example of how do you convert data set from various other ways also, but this is one of the way. If your data in the memory, and from that memory you want to convert data sets, you can say you have a sequence, this is Scala sequence, and say two data set, and you are passing, this person class, and which has, name, this name and this age, and you're converting to data set, and you can do this. If you want to, if you have some sequence array, this is an array. One collection contains 3 elements, 1, 2, 3. You can convert integer also like this to data set, and you can do any operation. This is one of the transformation. Map is one of the transformation and collect is one of the action. So you can map here. I'm adding just one to each integer and collecting at the end. Question is, nowadays we are using data. You absolutely, we in the, we should always use data frame as much as possible, or data set. RDD we should avoid, but sometimes if RDD, sometimes you might need to use RDD. So maybe you are getting image or video, you are processing image or video. That time you might need to use RDD, but most of the time you are dealing with structured data. So at that time you don't have to, use RDD. You just use the data frame or data set. Now I will just, what I will do is I will not cover this, but what I wanted in some session was, maybe in coming week, is I want to read data from the database and create a data frame out of it. So this is one thing which you can use, over the week, coming week. You can go to this website dbforfree.net, sign it up, and there it gives you MySQL free instance. You can create one database, give your username, give your password, and give your email address. So it creates a RDB data, it creates a MySQL database for you. What we will do is we'll populate some data into this and using Spark, and we'll read it back using Spark. So in your spare time, before next Saturday, just try to create one, thing here. And remember, this is transient. After some days, it will get deleted. So make sure by Saturday when you come, you have something created here. I will stop it here. I think I will stop at this data sets. It can be data sets can also be manipulated using functional transformation, map, filter, or flat map, etc. It's available in Java and Scala. It's not available in Python and R. Homework for you to guess the reason why it's not available in Python and R. So do that reading, and I will stop now. I am opening up for questions. Let me stop the recording also. Recording.